Now we are studying about the reflection of light. Some points are remember to understand the concept of reflection. Luminous body, a body which emits light itself is called a luminous body. So examples of luminous bodies are stars, sun, fire. Non-luminous body, a body which does not emit light itself is called a non-luminous body. A non-luminous body is seen by the light reflected by it. Examples of non-luminous bodies are planets, moon, buildings, trees. Transparent body, a body which allows most of the light to pass through it is called transparent body. Examples of transparent body are air, glass. Translucent body, a body which allows only a part of light to pass through it is called translucent body. An example of translucent body is oiled paper. Opaque body, it is a body which does not allow any light to pass through it. Example, wood, brick. Next, beam of light. A group of parallel rays is called a beam of light. In the convergent beam of light, as the beam progresses, the rays converge to a point. In the case of divergent beam of light, as the beam progresses, the rays diverge from each other. Light is a form of radiant energy. Light causes the sensation of sight. Darkness is the absence of light. Light can produce mechanical, chemical, thermal and electrical changes. Photography is based on chemical changes caused by the light. Light travels in a straight line. It can travel through vacuum with a speed of 3 into 10 to the power of 8 meters per second or 3 into 10 to the power of 10 centimeters per second. Whereas light waves can pass through vacuum, sound waves cannot. Light waves are transverse waves, while sound waves are longitudinal waves. These points are very, very important. When the rays of light falls on the surface, they are turned back into the same medium in accordance with the definite laws. The bouncing back of the light from a smooth surface is called reflection. The point of incident is that the point at which light is incident on the reflecting surface. The perpendicular drawn to the reflecting surface at a point of incidence is called normal. Any ray of light that strikes on reflecting surface is called incident ray. The ray of light which is turned back after reflection into the same medium in which the incident ray is traveling is called reflected ray. Laws of reflection. There are two laws of reflection. The incident ray, the reflected ray and the normal at the point of the incidence all lie in the same plane. The angle of incident is always equal to the angle of reflection. These two laws are very, very important in the concept of reflection of light. The real image is formed when two or more reflected rays intersect each other at a point in front of the mirror. It can be obtained on a screen. Very important point. A virtual image is formed when two or more reflected rays appear to intersect at a point behind the mirror. It cannot be obtained on a screen. This point is also very important. Any smooth, highly polished reflecting surface is called mirror. This is the definition for mirror. A plane mirror is a highly polished plane surface. The image formed by a plane mirror is erect and virtual. Very, very important. It is a laterally inverted image. The image formed is of the same size as that of object also. The image and the object are equidistant from the mirror. These points are very, very important. When an object is placed between two plane mirrors inclined at an angle of x degrees, then the number of images n formed by the given formula. N is equals to 360 by x. A kaleidoscope works on the principle of multi-reflections. Very, very important point. A spherical mirror is that mirror whose reflecting surface is the part of hollow sphere of a glass. In case of concave mirror, the reflecting surface is inside, while in the convex mirror, the reflecting surface bulges out. The center of spherical mirror is called pole. The center of the imaginary sphere to which mirror belongs belongs is called the center of curvature. The center of curvature of a concave mirror is in front of it, but the center of curvature of convex mirror is behind it. Very, very important. The radius of the imaginary sphere of which the mirror is a part is called radius of curvature. The straight line passing through the pole and center of curvature is called principal axis. The distance of the principal focus from the pole of the mirror is called focal length of the mirror. It is denoted by small f. If r is radius of curvature, the mirror of focal length f, we can write r is equals to 2f. This is also very important principle. Mirror formula is a relation between the focal length of f of the mirror, the distance u of the object from the pole of the mirror, and the distance v of the image from the pole. Now, new Cartesian conventions. In the case of spherical mirror, the following sign conventions is used for measuring various distances. All distances are measured from the pole of the mirror. All distances measured in the direction of the incident ray are taken as positive. All distances measured in the direction opposite to the incident ray are taken as negative. The distance measured above the principal axis are taken as positive. The distance measured below the principal axis are taken as negative. According to the mirror formula, 1 by V plus 1 by U is equals to 1 by F. 1 by image distance plus 1 by object distance is equals to 1 by focal length.